So in this video, I'm going to be showing you guys how to find sine, cosine, and tangent of different angles. But to do that, first let's go over what a reference angle is and what a coterminal angle is. A reference angle is the angle that the given angle makes with the x-axis. And it's usually between 0 degrees and 90 degrees. So all the angles in the first quadrant are all reference angles. And in order to determine the reference angle for any angle in the second quadrant, you would have to take 180 degrees and subtract it from that angle, because that would tell you the difference that there is between the x-axis and that angle. For quadrant 3, you would have to take the angle and subtract it from 180 degrees to find the difference. And for any angle in the fourth quadrant, you would have to take 360, because that's the closest angle to the x-axis, and subtract it from the given angle that you were looking for. A coterminal angle is any angle that ends in the same place. So if you have an angle and you go around in a whole 360, then you'll be in a different angle, and those two angles would be coterminal because they ended up in the same place. And you could also go backwards. If you subtracted 360 degrees, you would be in a different angle, and that would also be a coterminal angle. So the difference is either plus or minus 360 degrees. Angles can be represented in both degrees and something called radians. Radians are usually represented as pi, and degrees have that little degree symbol at the top. Always remember that degrees go counterclockwise, so you can start off at 0, then it goes to 90, then 180, 270, and then it goes back to 360. And this section over here is quadrant 1, then you have quadrant 2, quadrant 3, and quadrant 4. Alright, so let's work on some examples. So if we wanted to find the reference angle of 240 degrees, in order to do that, we know that 240 degrees is in the second quadrant. So we would have to take 240 and subtract from 180. So how much is that? This means that our reference angle is 60 degrees. If we wanted to find out the reference angle for 495 is bigger than 360 degrees. So in order to get what the reference angle is, let's try to get it between 0 and 360. So we would have to find a coterminal angle. So let's take 495 and subtract 360 to get it into that range. So our new angle is 135, and this is a coterminal angle, because all we did was go backwards 360 degrees, and we ended up in the same place. So we can use this angle to find our reference angle. And to do that, since this angle is in the second quadrant, we can now take the angle, we can take 180 degrees and subtract that from 135 to get what our reference angle is. So our reference angle is 45 degrees. For the next example, 11 pi over 6 is an angle in radian form. And we know that the reference angles mainly in quadrant 1 are 30, 45, 60, and 90. 30 degrees can be represented as pi over 6 in radians, 45 degrees can be represented as pi over 4 in radians, and 60 degrees can be represented as pi over 3 in radians. And 90 degrees, since 1 pi is 180 degrees, 90 degrees is pi over 2. So the reference angle for 11 pi over 6 is just pi over 6. And that's because 11 pi over 6 is the same thing as pi over 6 multiplied 11 times. And one easy way to determine the reference angle whenever it's in radian form is just by looking at the denominators. So in this case, they're both 6. This means that the reference angle for negative 9 pi over 4 is just pi over 4, because again, they have the same denominator. So sine, cosine, and tangent have different signs on each of the quadrants. For example, in quadrant 1, all of the trigonometric functions are positive. In quadrant 2, only sine is positive and its inverse cosecant. In quadrant 3, only tangent is positive and its inverse cotangent. So that means that every other trig function is negative in quadrant 3. So that means that cosine and sine are both negative. And in the fourth quadrant, only cosine and its inverse, which is secant, is positive. Everything else is negative. And that there is an easy way to remember that. There are mnemonic ways of remembering this. One of them is that you can remember this by saying all students try cheating or all students take calculus, whichever you prefer, whichever seems most enjoyable to your memory. So if we wanted to find sine, cosine, and tangent of 240 degrees, one way of doing it would be to find the reference angle. From before, we know that the reference angle of 240 is 60. So sine of 240 is equivalent to the sine of 60. And from here, we can use our table to figure out what sine of 60 is. Sine of 60 from our table is radical 3 over 2. So this is the square root of 3 over 2. But we have to consider the angle that we have. Since we have 240 is in the third quadrant. In the third quadrant, only tangent is positive. So since we're working with sine, we know that this has got to be negative. So our answer, the sine of 240 is negative square root of 3 over 2. So we can do the same for cosine of 240 and tangent of 240. So cosine of 240 is equivalent to cosine of 60. And cosine of 60 is 1/2. But again, since it's in the third quadrant, cosine is negative in the third quadrant. So your answer is negative 1/2. For tangent of 240, it is equivalent to tangent of 60. And tangent of 60 is the square root of 3. And since it's in the third quadrant, tangent is positive. So for this one, we do have positive square root of 3. So you always just want to make sure that you put the correct sign depending on which quadrant you are working with. So it's actually similar with radians because for sine of 11 pi over 6, this is equivalent to saying sine of pi over 6. Because remember that pi over 6 was the reference angle for 11 pi over 6. And based on the chart, sine of pi over 6 is 1/2. But we have to try to figure out what quadrant it's in so that we can determine whether it's positive or negative. Since pi represents 180, that means that it's taking 180, the top portion, and it's splitting it up into 6 pieces. And it's doing that for every 180 pieces. That means that for the bottom half, it's also being split up into 6 pieces. So to find which angle is 11 pi over 6, we can count. This would be pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, which is pi, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. So that means that 11 pi over 6 is this angle right here. And that is in the fourth quadrant. So since 11 pi over 6 is in quadrant 4, that means that sine is going to be negative. So knowing what quadrant it's in is very important. And we can do the same thing for all the other trig functions. So for cosine of 11 pi over 6, that's the same thing as saying a cosine of pi over 6. And cosine of pi over 6, we can see from the table that cosine is just square root of 3 over 2. And in quadrant 4, cosine is positive, so that stays positive. And for tangent of pi over 6 is the square root of 3 over 3. And since it is in the fourth quadrant, it is negative. So if you wanted to find sine of negative 9 pi over 4, this would be the same thing as finding sine of the reference angle, which is pi over 4. And pi over 4, you know, is the same as the square root of 2 over 2. But we have to look for the sine. So we have to look for what quadrant it's in. So since it's pi over 4, half of it is being split up into 4 pieces. And since it's negative 9 pi over 4, we're actually going backwards. So this time, this part over here is negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4. So this here is 9 pi over 4. And so this is the angle that we are focusing on. So since it's in quadrant 4, this is negative. So for the next one, cosine of pi over 4 is just square root of 2 over 2. And the reason why you don't have to worry about the negative sign in front of the 9 pi over 4 is because that is just the angle. So you don't have to worry about that because we replaced it with the reference angle of pi over 4. You can add the negative sign either at the end or in this next step when we're transitioning from the reference angle. And so since tangent is negative in the fourth quadrant, this would be equal to -1.